Hi everybody. I'm hoping that that first little video sort of gave you a little bit of an introduction to what momentum is, and sort of why things work. And you can almost think about the reason that school buses are so big. It's not because, I mean, it's kind of because we want to carry a lot of kids at the same time, but it's also in case they're in an accident. The mass of the school bus is going to mean that the children on it are going to be safer. Because in an accident against a car, the bigger mass will probably win the battle. And most of the time, your school buses aren't going about 30 miles an hour anyway. So the M delta V of the school bus compared to the M delta V of a car that hits it or it hits, the school bus is going to win the battle, and the people on the school bus are going to be in much better shape. So I'm hoping that you can kick over to the worksheet, the examples that I've given you. It's a little packet that I'm hoping the substitutes handed out. And let's just dig in. The first page or so is all stuff that I hope that you got out of the video, but if you didn't, there it is. And then we can start looking at this. So after we get through these practice problems, they're called solved examples, I'm going to go ahead and assign the practice problems for tomorrow, and we'll see what we can do. So Tiger Woods hits a .05 kilogram golf ball, giving it a speed of 75 meters per second. What impulse does he impart on the ball? Well, there's two equations for impulse. One is J equals F delta T, and we're not given a force or a time, but we're also given the other equation, which is M delta V for impulse. So this is the one we're going to use because we have Tiger Woods hits a golf ball, giving it a speed of 75 meters per second. So I don't know how you hit your golf balls, but most of mine, when I hit them, aren't moving. So we know the VI for that golf ball is 0 and the VF is 75. We know then that the change in velocity, which is final minus initial, is going to be positive 75 meters per second. And the mass is .05 kilograms. So, plugging all that in, J equals .05 times 75, we can get an answer of 3.75 kilogram meters per second, which is kind of crazy because, a golf ball that comes off of a tee that fast only needs 3.75 kilogram meters per second of momentum to it. Next up, Wayne. I'll give you a guess who Wayne is if we're talking about a hockey puck. Wayne hits a stationary .12 kilogram hockey puck with a force that lasts for .01 seconds, which is 1 times 10 to the negative 2. I know that's how they give it to you in the problem there. Makes the puck shoot across the ice with a speed of 20 meters per second, scoring a goal for the team. What force does Wayne hit the puck? Well, this is the other momentum. So J equals F delta T, J equals M delta V. We're using this one instead of this one. So this is just straight up plug and chug. No, we're not. I'm just kidding. My bad. Long day. J equals M delta V, J equals F delta T. So we've got a mass, and we've got a time, and we've got a velocity. So we can actually sort of go back. We're going to use both of these actually. So the idea here is that since both of these equal J equals M delta V and J equals F delta T, M delta V equals F delta T. So I hope that makes sense. I'm just setting them equal to each other. So we know the mass is .12 kigs. The change in velocity was from 0 to 20, so that's going to be 20 meters per second, equals F, which is what they're looking for, times the change in time, which is .01 seconds. So I hope that made sense. I'm sorry, I kind of lost my own train of thought when I was looking at these equations. But if we do the math, .12 times 20, enter, that's going to be 2.4 equals F times .01. So we divide both sides by 0.01. We would end up with a force of 240 newtons by dividing by 0.01. 0.01. So I hope that makes sense. Sorry, I kind of screwed that up. Next up, tennis ball traveling is returned by Venus Williams. Yikes. It leaves her racket with a speed of 36 meters per second in the opposite direction from which it came. So it's going one way at 10 meters per second and goes the other way at 36 meters per second. What is the change in momentum of the tennis ball? And then if the 0.06 kilogram tennis ball is in contact with the racket for 2 seconds, or 0.2 seconds, what average force has Venus hit the ball? So we can figure out the first thing by change in momentum. So change in momentum equals m delta v. So delta p equals 0.06 times the change in velocity, which is final minus initial. So negative 36 minus 10, which would be negative 46 meters per second. V final minus V initial, it's going to the left negative 36, and it was going to the right 10, so negative 36 minus 10 would be negative 46. Because momentum is a scalar, it means that the momentum shift is going that way. 0.06 times 46 negative, we would end up with a change in momentum of negative 2.76 kilogram meters per second. And then if the 0.06 kilogram ball is in contact with the racket for 0.02 seconds, what's the average force that we're hitting the ball with? Well, now we can do, again, delta P, the change in momentum is caused by an impulse, so J equals F delta T. So now I know J, which is negative 2.761, that equals F times the delta T, which is 0.02 seconds. So I can take, I'm sorry, that's not 2.761, that's just 2.76. There we go. So now what I would do is divide both sides by 0.02, and I would get my force divided by 0.02. And you would have a force of negative 138 newtons. So that would mean that her racket would be pushing that way with 138 newtons on a ball that was going initially to the right and then finally to the left. So I hope that makes sense. I'm sorry that my math is all kind of, hidden down in the corner. Finally, to demonstrate the new high-speed camera, Flash performs an experiment in the physics lab when he shoots a pellet gun at a pumpkin to record the moment of impact on film. The 1 gram pellet travels 100 meters per second until it embeds itself 2 centimeters into the pumpkin. What average force does the pumpkin exert on the pellet? So, this is going to be interesting. First, we've got a couple of units. The 1 gram is 0.001 kilograms. Let's start with that. And then we've got 2 centimeters, or 0.02 meters. So we got to get rid of those bad units and use those good units. So, what are we going to do? We are looking for the average force, and the only way we're going to, the only equation we have to get force is F delta T, which equals impulse. But impulse is also the change in momentum, which is not F delta T, M delta V. M delta V. So the force we can find if we know the time, which we do, or can we figure that out? Oh, we can't. So this is even kind of not so great. This is actually going to take a little bit more ingenuity than I had originally planned. Sorry about that. So we have the force, or we can find the force, but we need to figure out the time because we have the momentum and we have the change in velocity. So to figure out the time, we have to remember something that goes all the way back to kinematics, which is velocity. Velocity is distance over time. And therefore the change in velocity is the change in distance over the change in time. This is old school. Anyway, so change in velocity is going to be 100 meters per second because you start, or negative 100 meters per second. And the change in distance is going to be 0.02, and the change in time is what we're looking for. So to solve for that, we'd solve for time, or we'd multiply both sides by time, and then divide by 100. So 100, sorry, 0.02 divided by 100 is going to be 0.0002 seconds. So that's how long it's going to take this thing to stop. So now we've got F times 0.0002 seconds, which equals the mass, which is 0.001 kilograms, times the change of velocity, which is negative 100 meters per second. And then we can figure out all this good stuff. So 0.001 times negative 100, that's going to be negative 0.1. Then we're going to divide both sides by 0.0002. Divided by 0.0002, you will end up with a force of 500 newtons. That's going, negative 500 newtons. That is working on this this pellet. So here's the pumpkin, or apple, or whatever, and the pellet goes in. So if the pellet's going this way, the pumpkin is pushing negative that way. So I hope that makes sense. And if not, I wouldn't get too, this idea is very important. Figuring out the time can be somewhat enigmatic, but it's an old equation that we've got. It's from the old Stanley Cup top. Anyway, so after this, you should be able to take a look at numbers 1 through 6 for the rest of the class and try and work on those for homework. I hope these two videos helped, and I hope to see you all soon.